This is a lesson on conditional statements. So the original statement we're given is, if it snows, then they cancel school. This part right here, it snows, is what we would call the hypothesis. The second part here, they cancel school, that part is what we call the conclusion. So an if-then statement has both a hypothesis and a conclusion. The if part is your hypothesis, the then part would be your conclusion. So if you're asked to find something called what we say is the converse of a statement is when you change the hypothesis and conclusion in position, or you interchange them. So, for example, we started with this hypothesis. We want to end with it if we're going to do the converse. So our if-then statement becomes, if, we start with this, they cancel school, then we conclude with the original hypothesis. Then it snows. So is this a true statement, or what is its truth value? Well, there could be other reasons that they cancel school. So we could say that this is false. Let's go into the inverse. Inverse is when we do the negation of both the hypothesis and conclusion. So here is our inverse. We keep the hypothesis in position if, and we're talking about it snowing, we're talking about it, where is it? It's snowing, but now we want to negate that, so it's not going to snow. If it does not snow, now let's go back to the original conclusion, we also want to negate this. They cancel school, so then they're not going to cancel school. If it does not snow, then they do not cancel school. Then we're going to jump into what we call, I'm going to kind of leave this one at the top here actually. We're going to go into something we call contrapositive. Contrapositive occurs when you interchange both the hypothesis and conclusion, and you negate both as well. So our original hypothesis of it snows is going to come second. So we're going to start with they cancel school, but we're going to negate that. So if they do not cancel school, then we're going to negate this as well. It does not snow. Contrapositive, it's important to note that it always has the same truth value as the original conditional statement. And then lastly, let's talk about biconditional. A biconditional statement uses an if and only if. Typically, the only part is true when only both parts, not typically, it is always the case. It's true when both parts have the same truth value. So if you've got your P, you've got your Q, and we're going to do if and only if of P and Q. If these are both true, they have the same truth value, then they'll be true. But if one of them is true and one of them is false, it's going to be false. If one of them is false, one of them is true, it's still going to be false. They have to have the same truth value. So notice these two have the same truth value. They're both false. Therefore, we could say that the if and only if part would then be true. So let's look at an example. Let's say P is going to represent a polygon, is a triangle, Q is going to represent a polygon has exactly 3 sides. So then, when we go for our statement here with the if and only if, we could write, a polygon is a triangle if and only if it has exactly 3 sides.